Today we're going to look at radical division with monomials, one group on the bottom of the fraction. So there's multiple ways of going about doing these problems. One way is not better than the other, one's not more correct. There's just multiple directions you can go to get to that same answer. So starting off, first question. One big square root and inside you have 16 divided by 4. Sometimes when you see one big square root, you're allowed to break that up into two smaller ones if you like. Sometimes this just helps recognize what you have going on in front of you. When I do that, I can now see I have square root of 16, square root of 4. They're both perfect squares. I could just say 4 over 2. And then always want to simplify as much as possible. If you can, 4 divided by 2 gives me 2. How else could I have done that? Well, I could have jumped right from the beginning and said 16 divided by 4. Inside this is going to be a 4 inside the radical, and then the square root of 4 brings us still right back there. One's not more right than the other. Okay. Next question. I see that I already have a square root of 4. I like that. I'm going to simplify and give myself a 2 there. And normally we'd say, let's call it a day. There's nothing else you can do. However, when we deal with square roots, when we deal with radicals, you are never allowed to have a radical in the denominator as a final answer. It is a huge no-no. You've got to get rid of it. So in order to do that, we need to manipulate our problem. We need to change it around. We're not changing its value, we're changing the way it looks. So if I multiply by a value of 1, I multiply anything by 1, I get what I start with. If I multiply by 1 over 1, it's still a value of 1. I can multiply with this, I'm still going to get that same answer. I can multiply by any number over itself, and I'm still going to get a value of 1. And the same thing that I started with. That's what I want to look for. I want to look to try and multiply by a value of 1. Now I get it by looking at my denominator. Here I have a radical 5. I want to multiply by a radical 5 over a radical 5. As long as it's a number over itself, no matter how ugly the number looks, it's still a value of 1. When I multiply by this, it's still going to be this answer. But we're going to kind of mold it a little differently. So let's see what happens. And why did I pick 5 under that radical? Because when I say 5 times 5, I get 25 under that square root sign. That is the same thing as saying positive 5 when I actually take the square root. That's my goal. I started with a number inside the radical, and now I no longer have one. That's what our whole goal here is, to get rid of the radical in the bottom. I don't care how ugly up top looks, the bottom cannot have the radical. So let's finish out up top. What are we left with? We've got 2 times radical 5. Can't do anything with them. I'm just going to bring them right to the end. And this 5's inside a house. This 5's outside a house. I can't cancel them. They're two different kinds of 5's. We call it a day and we move on. So next, we've got one that looks a little more complicated. We have a binomial up top. I know this 12, I could simplify. I could break up into a 4 and a 3, and then I could do stuff from there. I'm going to hold off on that for right now. But I want to kind of keep up with this same process. I know I'm not allowed to have this. So this is what I want to move. This is where I want to put my focus. So I'm going to multiply by a value of 1. That value of 1 is going to be radical 12 over radical 12. A number over itself, 1, it's not going to change the value of this, just change the way it looks. Up top, we're going to have to distribute. So we get negative 5 radical 12, and then we have negative radical 36, all over square root or radical 144. Now the beauty here, that is a perfect square. That's going to give us a 12. So I know I get 12 on the bottom. Up top, this is going to give us a 6. So we have a 6, we got a minus sign, and then negative 5 radical 12. Okay, Can we call it a day? Uh-uh. I got to do something with that 12. I got to break that 12 up. So normally I know 4 times 3. Well, let's take this one more step further. This 4 is going to give me a 2. What is 2 times negative 5? Going to give us a negative 10. That 3 stays inside. We're left with 6 and then 12. Are we finally done? No again. Why? Well, this time 12, 6, and negative 10. All these numbers that are on the outside of the house, not the radical, they're all even numbers. They all share something. The number they all share is 2. I want to cut this 10, 12, and 6 by a 2. I want to divide everything by a 2, cut them all in half. All right, one final one. We're going to have negative 5, radical 3, minus 3, all over 6. Finally, there's your answer. And that is dividing radicals with a monomial in the bottom.